skill 2 will be doing something very elaborate. It's the biggest derivation you have in your entire physics, okay? So, puro class lege jay. The derivation has like multiple subtopics in it as well, okay? So, yeah, before I start, this is the ideal gas assumptions, okay? And these assumptions are like explained here in details. We saw the ideal gas equation and some of the features such as why does pressure increase with decrease in volume? Why does pressure increase with increase in temperature? So that's all we did so far. আজকে যেটা করব ওইটা হচ্ছে page, so there's a whole page given dedicated for it, page 58 and 59. So first go to page 58. Page 58, yeah. So the way I approach and the way the syllabus approaches is a little off, but eventually we meet at the same place. For example, a 15.3 they ask you what are the basic assumptions of kinetic theory of matter. I feel like you need to know it at the start. Okay, so I do that at the end. So we're done with this. Tapabolchi, explain how molecular movement causes pressure exerted by gas. We did that last class. So how is pressure exerted? The particles collide with the walls of the container. As they collide with the walls of the container, what do they apply? Force. And the force exerted per unit area provides what? Pressure, right? So that's what we saw. And derive and use the relationship PV equals to 1/3 NMC square. That's the formula, okay? So we're going to derive that today. And to derive that, we need to understand many more smaller topics, which is essentially this whole topic, okay? So derivation we will be done with that. That's the end of it, okay? Right, so assumptions just one more time. They're identical. Elastic behavior, volume is negligible compared to the volume of the container. There's no other forces other than impact. So basically there are two versions of this, and the molecule is in random continuous motion. What do we call this random continuous motion? Brownian motion, okay? Right, so now we will derive an equation. Equation I page derive for 59 okay? So we're gonna start from scratch. I would recommend don't write anything. If you understand this first time around, right, you hopefully never forget. Okay, so that's a test for you. Okay, so let's derive this. So our derivation begins with this criteria we need to set, that we are trying to find out the pressure exerted by a gas in a closed container, and the closed container has certain dimensions. So dimensions look key. So this is the container that you have, and the dimensions of the container are x, y, and z. Okay, so 3 dimensions here: x, y, and z. 3 sides of this container. Are you clear? And we have a particle inside the container, which is going to be shown with this dot here. That's the particle. And this particle, that's too big, sorry. That particle that we have here is of mass m. So that's my particle here, mass m. And the particle is moving like this towards the wall with velocity v and mass m. This is what we know before we start. Okay, so before we start the derivation, we know that we have a container. Their dimension, let's say x, y, z. X centimeter, y centimeter, z centimeter, meter, doesn't matter. The mass of the particle is m. What mass? Individual particle. So just one particle at a mass, let's say m. And the velocity of this particle is v. Now, in 3-dimension space, it's difficult to visualize for some students. So we'll take the side view as well. And we'll look from this side, where this is going to be x, and this is going to be z, and the particle is going to be here. And this view is very important because we'll be doing some math based on this. And the particle that you see here has mass m and velocity v. So far, I hope you're clear. Groundbreaking coin. I'm just setting the premise here. So yeah, this is what we have going on right now. So let's start with the first thing. The first thing is we need to find out the force of impact. Okay, so I'll break the derivation down into parts. Force of impact. How can we find the force of impact based on the information provided here? By the way, information আমরা নিতে পারবো না। আমাদের যে information provide করা আছে ওইটা use করে বের করতে হবে, okay? So can you tell me how can I find the force exerted by the particle as it collides with the wall? How? Right, very good. So force is going to be change in momentum divided by time for the change. So time of impact bola hoy, but ekhane to true impact hoy na. So time of momentum change. P, by the way, is the symbol for momentum. Do you agree what I've written here? Acha. Now, can you tell me what is going to be the momentum change here? So let's try to see. So the particle here, a particle it's going to go the other way. And as the particle goes the other way, the mass is still going to be the same. The velocity will still be the same. With one exception though, what is it? Minus, right? So the velocity is going to be minus. So based on this information, can you tell me what should the formula for change in momentum be? Yes, right. So the force here exerted is equal to mv, or final energy minus v, minus mv minus mv divided by t. Do you agree? Because final is m minus mv, initial is mv. So therefore, the force, and this is our first expression. No, not ideal gas equation. P equals 1/3 nmc squared. It's another equation. But it's one of the ideal gas equation substitutes. So P equals to minus 2 mv divided by T. Okay. এখন, next step. So we are done with force, and you guys did well. Like force bear korte par. So I need to know time to down. Because I told you I only have this information: mass m, velocity v, x, y, z. How do I find time? What would I do to find time? So there's a hint in the expression I've provided. It says change in momentum divided by time of momentum change, right? So how can I find time here? This particular part, I think is a little challenging. Velocity is constant, right? We assume on average is constant. Yeah. Achha, very good. Yeah, that's not bad. That's a good start. Achha, one of you have a question here. Positive 2 MB. Last class, yes. Last class I actually gave this as plus. Does it matter? No, I mean, our plus minus depends on which side you take your direction. So plus minus is not a problem. In fact, I'll get rid of the minus very soon. So time back for you. So how to find time? So time is its own derivation. So time of impact. Eta to unrealistic approach kora hoy, but it works. So ora ki kore to dekho. They assume, and listen carefully, okay, it's very easy to get lost here. They assume that the impact with this wall is this whole thing. Normally, I'm a key consider good impact the moment it touches the surface, right? Isn't that what we call the impact time, the contact time? But there is no real contact here. You do understand that, right? The particles come very close, stop, slow, and then go back. So what do they consider the impact here? So they consider the impact that your particle will go from here, hit there, and then come back here. That entirety is considered the impact time. And it is actually justifiable to a degree. I'll tell you why. The particle is moving extremely fast. Imagine a particle going in this room close to the speed of light. It'll go back and forth a billion times in a second. So ও যে এই ওয়াল থেকে বাড়ি খেয়ে ওইখানে গিয়ে বাড়ি খেয়ে ব্যাক করতেছে ওই টাইমটা আর কন্ট্যাক্ট টাইমটা they're very similar. There's a barely contact করতেছে. I'll give you better reference on this, okay? So imagine there's a ball falling here and the ball is falling for 2 seconds or 10 seconds. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it split second collides and then goes back up. Within that 20-second movement, isn't the contact time very small? তাহলে আমাদের কিন্তু assumption করাটা wrong হবে that this whole thing is the contact time. Because the contact time is few milliseconds, whereas this is what, 10 seconds down, 10 seconds up, total 20 seconds, right? But imagine that the particle itself took 1/1,000,000th of a second to come here and then takes 1/1,000,000th of a second to go back there. Compared to that, contact time, isn't it very similar? But the point I'm trying to make is that the full motion compared to the impact is more similar in gases then let's say a ball being dropped. So we make an assumption here. The assumption we make here is that the time taken for the particle to go from here, collide and come back here is similar to your what time? Contact time. So we are just replacing that. For what reason? For no other better option. That's the actual reason. But now there's no option. So we don't have like a stopwatch or timer or anything there, right? So আমরা যেটা assume করবো, so ideal gasের হচ্ছে assumption হচ্ছে particles only travel in straight line, back and forth, up and down, left and right. Okay, so angles se jana. So we make an assumption here. The time of impact is the time for the total motion back and forth. So এটা কি হবে তার মানে we're not done yet. So আমার যে পার্টিকেলটা হচ্ছে হ্যাঁ বলো করা যায় না। So আমরা স্পিড মেজার করতে পারি কারণ কন্টেইনার সাইজ জানি তো ওটা দিয়ে টাইমটা বের করি। So actual measurement করা possible. So how do I find the time? So what is the distance travel on the way in? X. And what's the distance travel on the way out? X, right? So distance. So it's going to be X as well. So if I want to find time here, I'll use what formula? Speed equals to distance by time. Speed tells আমরা assume করি it's an elastic impact, so the speed remains what? Constant. So V equals to 2x divided by t. Therefore, the time of impact is what? 2x divided by V. Eventually these all round up to like a very nice equation. Okay, so this is one of those steps just for the time in assume. So yeah, we have our time here. So we take this equation and we take that equation and we combine here to get an equation for force based on all the quantities we have found so far. So F is going to be equal to minus 2mv divided by t ki hobe 2x by v, which is going to be 2mv square hobe na 2 ta mone kata jabe. So the 2 goes away. So what do you have here? Yes, mv square by x. Minus থেকে আমরা ignore করব because minus the subjective. It's just কোন দিকে force হচ্ছে ওইটা minus রাখতে। হ্যাঁ sorry. So আমাদের যে ডাবল হলো ওটা মাইনাস right? এখন তুমি মাইনাস চাইলে রাখতে পারো সবকিছু শেষে মাইনাস এমনি বাদ দিতে হবে because you're going to find pressure at the end. And pressure is the what quantity. So minus eventually has no implication there. Okay, so yeah, চাইলে minus রাখার problem নেই. Okay, I'll put a side note here. Negative is not important from here on. Okay, so tajma minus the baad dilam. So what's the formula for force exerted by a particle on the wall of the container? mv squared divided by x. Acha, আমাদের কিন্তু by the way যারা জানো না ফার্স্টে বলছিলাম what are we trying to achieve here? A formula for pressure. Acha, so force বের করলাম. Is time of impact when the ball hits the wall is the time of impact. Yeah, so the time of impact is the time it hits the wall. But the thing is, the particle is going so rapidly back and forth. We can consider that this whole motion as the impact. And it is only doable because the particles are moving very fast in a subatomic level. You can't do that with a ball hitting a wall, but you can do it here. Okay, so this is the expression. Eta is one derivation that you get. So এটা বলছিল না 15 marks derivation, 15 marks derivation দেয় না কোনো সময়। ওরা কি করে এরকম breakdown করে দেয়। So they'll ask you just to derive the force. Next, we'll go for pressure. So pressure formula হচ্ছে কি হবে? Pressure equals to, yeah, exactly. Pressure equals to pressure on wall. So pressure on wall is going to be force divided by area. এখানে একটা interesting assumption করা হয়. What is the force as we have found so far? Yeah, mv square by x divided by, can you tell me what is the area that the particle collides with? Yeah, so the area the particle collides with, some students will feel like it should be this, the actual area. আমি যে জায়গাটা এখন highlight করব, like that part, right? Because that's where the particle collides. But here's the thing, okay, try to imagine this. You have this cardboard, and cardboard mode you fire like a or you throw a ball at the center. Just does the center only move or the whole cardboard moves? Yeah, so isn't the force exerted on the entire cardboard if the cardboard can move on its own? You get what I'm trying to say? So let's say you have a cardboard, right? Just like a board, and you throw a ball at it, right? Of course, je jaga ball ta badi khai will bulge more, but wouldn't the whole cardboard move as well, right? So where is the force being exerted over the entire thing, right? So আমাদের এখানে যেটা করা হয়, we assume that these particles that are colliding with the walls of the container, they're exerting force on the entirety of the container. So the area that we take is not going to be that, it's going to be the whole area here. What should that be? Y into Z, right? So I'll put notes on this, Y into Z, which means you get mv square divided by x, y, z. What could x, y, z be? Volume, right? So finally, we have this very nice equation here, mv square divided by what? V. Volume is the container volume. Okay, are you with me so far? Acha. So you have P, V, and divided by volume here, and this is the expression for pressure. এখন প্রবলেমটা হচ্ছে, this velocity that you see here is the velocity of which particle? This particle, right? But does all the gas particles in a container have the same velocity? No, right? The whole kinetic theory of matter is based on the assumption that all the particles have different velocities. There's an average K out there. My question is, so now this is a new topic that I'm making out of the box. How to find mean velocity? I need to find average. So mean velocity can be very close. So do you guys know how to find mean in or how to find mid value in math? The three ways. What are those? That's one way. Yeah, mean, median, mode. Mean, median, mode. Mean is what? Average. Median is you stack them up from ascending order. Middle value to very korba. Our mode is the one that repeats itself the most, right? Acha. These in statistics, right? Once you start doing statistics, do you guys have statistics? Acha, that's what So can you tell me how to take averages of quantities that have negative in them? Let me clarify. Down there, physics is this is the first time we're going to do it. So imagine you have your gas particles in this very random scenario where the gas particles happen to be moving back and forth. And these particles, they all have different velocities. And I'm going to average the weight. But their velocities are 500, 500, 600, 600, and 400, 400. Right? So এখানে যদি আমি average break করতে যাই, this is velocity, right? Shouldn't one of them be negative? So negative, negative, and negative, right? If I do find the average the way you guys are taught, right, I'll get an average of what? 0, right? Which is not true, because if you plug that value in your answer, right, it goes on pressure, because velocity is 0. So how do you find the average when you have plus and minus? It's a statistics শিখায় তোমাদেরকে, no? আচ্ছা আমি যখন ফাইনালি বলবো you'll realize you have learned it, but তোমাদেরকে ওভাবে মার্কেট করা হয় না। না, ওটা তো হচ্ছে weighted average, ওটা different. হ্যাঁ, so যে first thing students come to is that just get rid of the minus, right? You can't do that. It's just not something you can do in math. So how can you get rid of minus? You can multiply the number with -1. একটা minus number কে যদি multiply with -1, doesn't it become positive? But তাহলে যেটা positive ওটা কি হয়ে যাবে? So you have to do something that's universally going to work, right? So some students will go like do modulus. You know what a modulus is? So modulus can't work here. Or graphical interpretation is not like possible. You can take the negative to the positive, but absolute value to power that. So there's actually a statistical approach. I mean, it's not physics. So the statistical approach is first step. A step to carefully 3 marks একটা math দেয়. First step হচ্ছে you're going to do square the numbers. And it turns out squaring is a very good way of getting rid of minus. You know that? Like if you square any negative, right? So square the numbers. So you can join numbers go square all of them. So the plus will also be plus, the minus will also become plus. And I've not done something biased. So you'll get 500 squared. আর তারপর হচ্ছে minus 500 squared 400 squared. See the process, acha? And it turns out what we're going to do right now is the most advanced, most ঠিক বলবো না, but one of the more advanced ways of finding an average out there. So যখন হচ্ছে they find averages, mostly in economics use করা হয়, এটা করে আমি বলি কি করে. So that's the first thing. What did we do here? We squared the numbers, right? Number 2 হচ্ছে you find the average now, mean. Okay, so mean বের করব. কেমনে বের করব mean? I'm going to take all of these numbers, তারপর কি করব? Add করব, and then what will I do? Yeah, I'll divide by 6. Very good. So can আমাকে একটু help করব এখানে? Yes. কোথায় করছে এটা? Yeah, statistics কোন টপিকে? Standard deviation. Okay, it's called the square of mean and mean of squares. Do that. Okay. Anyways, ব্যাপার না. So can you tell me what is the average here? It will be like a large number. 2546. 256,666.67. ওকে, ঠিক আছে, ব্যাপার না. সো এদিকে দেখো, এটা হবে ইউনিটটা কি হবে, ইউনিটটা একটু দেখি নেই. সো আমরা এখানে স্কোয়ার করছিলাম, স্কোয়ার করলে আমার ইউনিটটা হয়ে যাবে হচ্ছে মিটার স্কোয়ার পার সেকেন্ড স্কোয়ার, ভেলোসিটিকে স্কোয়ার করলে, রাইট? আর যদি মিন বের করো তাহলেও কিন্তু মিটার স্কোয়ার পার সেকেন্ড স্কোয়ারই থাকবে. আর ইউ উইথ মি সো ফার? হোয়াট আই এম ট্রাইং টু সে? আচ্ছা, মিটার স্কোয়ার পার সেকেন্ড স্কোয়ার. এখন the problem is এটা তো velocity না, so I have to get back my actual value. What can I do? Root them, right? So last step হচ্ছে root the value. So করো কি আসে দেখো. Yes, and you will find that once you take the square root of this number, you get a number that's like something similar to we have seen before. 506. 506.6 meter per second, and this is a much more better average than what you normally do. So whenever you have data out there in scenarios where there are a lot of variations out there, and there could be a negative in it, we use this thing, and there's a name for it. The name is very easy to remember. The name is basically the instruction. The name is, you will start here, root mean square speed, RMS বলে এটাকে. Okay, so root mean square speed আছে, root mean square voltage আছে, root mean square আরো অনেক কিছু আছে. ওই root mean square টা is not a physics thing, it's a statistical approach. You find average of squares. Okay, so first কি করবা, you're going to square it, then mean it, and then root it. Okay, so a approach টা করলে you get the most accurate average out there. It's called the RMS velocity. So I'll add it here, root mean square velocity. Right, so there is a symbol for it. So symbol টা হচ্ছে যে এটা bracket এর মধ্যে c দিয়ে the your pointed bracket, right? So me that okay. So the symbol here for root mean square velocity is this. C use kori for velocity. Clear about that? Okay. So এখন আমরা যেটা করব, we will get back to our equation here. So we have learned a new quantity, so we'll introduce that here. A velocity v থাকবে না, velocity কি হয়ে যাবে? Yeah, so introducing RMS velocity, we will now get pressure equals to what? M root C squared divided by V. Clear? আচ্ছা, এখন লাস্ট স্টেজ ডেরিভেশনটা শেষের দিকে আমরা. হ্যাঁ, সরি. হ্যাঁ, এটা the velocity. হ্যাঁ, মানে ওই ভেলোসিটিটাকে আমরা হচ্ছে যদি এটা বেসিক্যালি ভি আর এম এস যেটা, ওটাকে আমরা এভাবে লিখি. ওকে, সো এটাকে আমরা স্কোয়ার করছি এখানে. বলো কি বলতে চাচ্ছিল? এটা কেন দিচ্ছে? এটা মানে আরএমএস ভ্যালু। সো তোমরা মেবি ম্যাথে শিখছো যে এটা মানে মিন, রাইট? হ্যাঁ, সো এই যে এটার মানে হচ্ছে আরএমএস। আচ্ছা, সো লাস্ট পার্ট হচ্ছে the final part here is the এটা একটু র্যান্ডম একটা জিনিস, probability of impact. আচ্ছা, সো এটা মাল্টিপল ওয়েজ অফ অ্যাপ্রোচ আছে। আমি তোমাদেরকে কোয়েশ্চন পেপার করার সময় I'll also show some mark scheme versions of it. I want to first explain here. So look at this. You have this container here. এই কন্টেইনার মধ্যে তোমার হচ্ছে পার্টিকেলটা যাচ্ছে back and forth. So see what's going to happen right now. Pay attention. So you have this particle here, and this particle is going to go this way, and it'll collide with the walls of the container. The formula that I got, right, will give me how much pressure it applies. But there's a small issue here. The small issue here is that one particle, right, won't collide with all the walls. The probability of one particle colliding with the walls of the container is not 100%. Because how many faces does a container have? 6, right? A particle that can only go back and forth, up and down, left and right, can only collide at max how many of these walls? 2, right? So is it possible that your particle, right, collides with all walls and applies pressure on all walls? No, right? So the application of pressure is actually what percentage of impacts on a wall? 1/3. Because your particle can go left, can go right, up, down, back, and forth. So if I consider them x, y, z actually problem of it, but let's consider them as 3 different orientations, right? So what is the probability of the particle colliding with any of the walls here? 1/3. So therefore, what we're going to do right now, এটা একটা description লিখতে হবে, এটা কোনো math বা কিছু না। So 2/6, there are 6 faces, and your particle going back and forth, right? How many faces of the 6 faces can it collide? 2. So the chance is 1/3. So it means that any particle can at max collide only 1/3 or 2/6 of the faces. There's another approach, it's math approach, okay? It's all math, but it actually calculation করে দেখানো যায়. So any particle can at max collide with 2/6 of the container at a time. Hence, probability is 1/3. So eventually, the pressure formula that we get, taking into account this and everything else that we have done so far, is the pressure P is equal to 1/3. What was the expression? mc square by v. Okay, এখন কিছু মডিফিকেশন করব এখানে আমরা। Right, so screen it to দেখে নাও. This is not the end though, there's a small addition here. This pressure is the pressure exerted by one particle. If I want to find the pressure exerted by all the particles, I'll have to multiply the pressure with what? Number of particles out there, right? So I will multiply this with the number of particles that we have, which is n, and তখন তুমি যেটা পাবা is 1/3 nm c square divided by v. Question for you, what is this? n n is the number of particles, because আমি যেটা বের করছি so far I found for one particle, right? If I want to find the total pressure exerted by all the particles, I'll multiply the pressure exerted by one particle into the total number of particles that I have. This is the pressure exerted by one of the particles. I'm multiplying this by total number of particles, right? So my total pressure is going to be this one. Now, can you tell me what is nm by v? Why? m by v. But এটা তো mass of one particle, volume of the whole container. Moles. Yes, Ambuli. a number of particles can you mass the multiply of one particle. Listen carefully, it's very easy. It's a parva. At a particular mass multiplied by the number of particles that I have will give me what mass? Total mass. Total mass by total volume. What does that give me? Density of gas essentially. So, but we say Nm by V density of gas. So eventually, this is the final equation. 1/3 rho c square. Okay, so that's the formula. Could be handy at the formula in gas laws. You can actually find the speed of your particles by just knowing what the pressure is of the atmosphere. 1/3 আমি আবার explain করতেছি. Just give me a second. So yeah, that's the entire derivation here. এখন 1/3 আমি একটু আগে explain করি. So look at this. আমার হচ্ছে 1/3 can use করা হচ্ছে. So there are a lot of other particles in this container, right? Right. So there are many other particles in this container, and they're all moving in different direction, up, down, left, right, forward, backward, right? But at any given instance, the pressure that they apply, is it the pressure that the whole container experiences, or is it the pressure only 1/3 of the container experiences? It's 1/3. Because I'm believe the problem is that if you didn't do 1/3, what are you assuming? Let's think of it that way. Let's say I'm doing 1/3 na kortam, what is the assumption? The assumption is that all particles collide with what walls? All the walls. Okay, but a particle can't collide with all the walls. It can only collide with how many walls out of the total at a given instance? Just 2 of them out of total 6, right? So what's the chance of your particle applying pressure on the whole container? 1/3. And to me, short particle can neither collide with all the walls. You find your values inflated. Why? Because your particle can only go back and forth. But what assumption have you made? It's colliding with all the walls. Wouldn't that mean the pressure is now more than before? The amount of impact is now more than before. But the thing is, the particle can only go back and forth, up and down, left and right. Yeah, that is another approach that out of all the particles out there, 1/3 of them can only collide with the 2 walls out there. So therefore, they're not applying pressure on all the walls. So what probability of the particles are actually applying pressure on your wall? 1/3. Okay, because I'm going to eventually be able to see the pressure exerted on this wall. So is it true that this particle, that particle is colliding with this wall? No, right? Which particle is only colliding with this wall? The one that goes back and forth. So for all the particles out there, what fraction will only collide with this wall? 1/3 of it, because the others are going that way and the others are going up and down. That's why the pressure that you get is actually less. How does it collide with 2 at the same time? No, it's not colliding with 2 at the same time. It's essentially the particle that you see here can go this way, that way, and that way, right? So this is the wall that we have. We're taking into consideration, and let's say there are 100 particles here. Out of the 100 particles, what fraction can collide with this wall? That fraction, let me draw up with that. I'll reframe my question. I'll reframe the question. The question is, let's say there are 100 particles in this container. How many particles can collide with this wall if the particles can only go in a straight line? 33.33. Why? Because the ones that go this way can't collide. The ones that go that way can't collide. The particles that can just go this way can collide. What fraction is that of the total number of particles? 1/3. So right, so that's the equation. P equals to 1/3 rho c square. Did they ever give this equation entirely? Once. Okay, long time back. I think 2011-12 ওরকম টাইমে। তারপর থেকে ওরা যেটা করে এখন they break it down. So they'll just ask maybe till this much, or এটা দিয়ে দিবে, এটা করতে হবে, or এই ম্যাথটা আলাদা করে করতে হবে, but actually কিছু এখন জিজ্ঞেস করে না। Okay. Yeah. So eventually, this is the equation that you need to remember. What are the parts of this equation? Let me just write it down for you. So the P represents the total pressure of the gas. Okay, total pressure of the gas, and rho is the density of the gas, not the particle. Density of gas, and this is what? What is that C? root mean square speed. No, the container's entire pressure. No, like, so all 6 sides are, so let's say you put a counter on a wall, how much pressure will you experience? Okay, which that would be the same for all walls, right? So that's the total pressure. So you remember the pressure right now is 101 kilopascal, right? The atmospheric pressure. Where is it 101 kilopascal? All walls together or any place? Or you're any place. Okay, total pressure will measure for the possible, because when you're looking at this wall, ওইটার pressure তো তোমাকে account এ নেওয়ার দরকার নাই, because you want to find the pressure here. So আমরা যখন কোনো সময় pressure বের করি, we find the pressure on that surface, and that surface is an equation. What is the capital N for? So yeah, I'll give like small notes next to each of these things. Capital N tells you total number of particles. So total number of particles in the container. Shouldn't that affect the probability? No, it doesn't affect the probability, because I have this container and I throw 100 spheres into the container, and the spheres are going just back and forth, up and down, front and back. And I want to know what amount of particles can collide with my wall here. If you do the math, it will give you this 1/3 of it can actually collide with the wall, right? So the pressure that I'm experiencing is due to 1/3 of the number of particles. See, I multiplied n here, right? আমরা কিন্তু এটা 1/3 এখানে না করে কি দিয়ে মাল্টিপ্লাই করতে পারতাম, n/3, same outcome, right? n/3 কেন? Because of all the total particles out there, only 1/3 of it collides with this wall, so that therefore eventually 1/3 তে চলে আসে. Okay, so start করি আমরা. তোমরা হচ্ছে ফার্স্ট এই দুটো করো, force of impact and time of impact. এটা by the way শেষ না, এটা আবার রেগুলার প্রায়োরিটি. This off করে দিলাম. তোমাদের এক্সাম হচ্ছে 15th এ, 15th এই এক্সাম, 15 থেকে শুরু হবে. You have capacitors. I know you guys normally UPS does after gravitational field electric fields. So you're done with electric fields. Electric fields, capacitors, and magnetism. Oscillation. Simple harmonic motion. When is it does? 17 আচ্ছা ঠিক আছে সিম্পল হার্মোনিক মোশন আমার হয়ে যাবে আবার জাস্ট ইলেকট্রিক ফিল্ডটা করাতে হবে ইলেকট্রিক ফিল্ডটা চ্যালেঞ্জিং আছে so I'll do extra classes do you have class during these days from 5 to 6 like after my class no I'll take extended classes okay I'll let you know kobe না ইলেকট্রিক ফিল্ড অসিলেশনস গুলো তোমাদের ওই টাইমের আগে হয়ে যাবে খুব ছোট চ্যাপ্টার সিম্পল হার্মোনিক মোশন But either way is fine. So you can either do that one particle can only collide with 1/3 of the walls and then multiply with the total number of particles, or out of total particles, 1/3 of the particles collides with the wall. So you can put 1/3 later or earlier. Can the RMS velocity used in the force equation? Yeah, you could have started with the force part there, but the problem is that the force equation is based on one single particle, right? So this V is for one particle. Eventually, when you want to find total pressure, you need to find the average. So that's why this is better place to introduce the RMS. So this all calculation here, these are all for one particle. And then once you find the pressure, that's for many particles. So you need to find the average. Done? Yeah. So no. So what does C mean is this. So you just need to mention that the velocity introduced in RMS means that this V is going to be C. Acha, arctic derivation is ready to correct the we'll be done with the chapter. It'll take 3 minutes, okay, and we have 6 minutes. So eta. So কি এটা একটু বুঝাই screen it to দেখো. I'll give you time later on if you want for that, but এটা দেখো. So you remember the formula PV equals to nRT. So that's the ideal gas equation, right? PV equals to nRT. এখন হচ্ছে there's a formula for mole number in terms of particles. What is it? I mean, if you want to find mole number based on particle number, what is it? Yes, very good. Number of particles divided by the Avogadro's constant, Na. N subscript eta is an official symbol for Avogadro's constant, right? 6.023 into 10 to the power 23. Clear about that? So, this is n number of particles. So, if I replace this mole number with that, right? So, let's say if I introduce this into this equation, so we'll get PV equals to n by Na times R into T, right? Now, then what I do is I take PV equals to N into R by Na times T. And R techie, what is R? Yeah, molar gas constant. So that is 8.31 joule per mole Kelvin. R হচ্ছে Na, Na কি mole number, which is also a constant. So am I not multiplying a constant by a constant? So when you multiply a constant by a constant, what do you expect? A new constant, right? And the new constant is K, and that is PV equals to NKT. And this equation is very handy for physics. Current physics say we deal with particles, not with moles. So যখন তোমাদেরকে কোনো math করতে দিবে, a formula makes more sense. PV equals to NKT. K has a name. The K is called the so if you calculate check করে দেখবা কত আসে 1.38 into 10 to the power minus 23 হওয়ার কথা আসে so 38 so basically 8.31 divided by 6.023 into 10 to the power 23 so এটা তোমাদের দেওয়া থাকে 1.38 into 10 to the power minus 23 joule per Kelvin. It's a constant different. Now, some other plus আসে minus 10 to the power 23 to niche minus. There are these. Yeah. Now, something else that I want you to know is that এটা কি K বলা হয় as for the DPS students. Do you know any other K? So তোমাদের সিলেবাসে there are 3 Ks. The 3 Ks গুলোকে establish আগে থেকে করলে confusionটা কম হয়. So you should know another K. What is it? No? Oh, it's evident. It's called the Coulomb's constant. K Q1 Q2 by D square. Coulomb's law of 2 charges. Oh, Hey, this is my friend. Hey. I thought he left. He has his own school. Oh, Jesus. He comes to play basketball. Anyways, but the K is called Coulomb's constant. Okay, Coulomb's constant is another K, and then we have a third K, which is the Stefan Boltzmann constant. So this is called the Boltzmann constant, by the way. So নামগুলো জানা দরকার, okay? And unfortunately, the most common symbol for constant key. K. Everyone, wherever there's a constant, they take it as K, right? This is called the Boltzmann constant. So Boltzmann's constant, and Boltzmann constant this value that you have. Just be aware of it, because খুব often যেটা হয় স্টুডেন্টরা সবকিছু জানে, লাস্টে গিয়ে কনস্ট্যান্টটা অন্যটা এখানে দিয়ে আসে, ওটা হচ্ছে 8.99 into 10 to the power 9. So that's not the one. Okay, so anyways, derivation কি বুঝছো? So when to use this one? When you're provided what in your exam? Mole number. When to use this one? When you're provided with what number? Number of particles. And physics say you'll find that number of particles is the most common thing that they provide. So yeah, there you go. Just reminder there ki jadar exam asche, I'll give you a schedule. Mostly hocchelo Mondays after class I'll do like thing for you, but tar age I'll provide you with some worksheets. Ogla kore class discuss kore better hobe. Okay, so molar gas constant. Do you have chemistry? No. Oh, sorry. You learn it in chemistry. It's a gas constant. 8.31 into 10 to the power